When you deal with electric continuity, the basic idea is to have a high potential, which is the black, that's an AC current, and the ground, which is the white. Between these two wires, the black and white, when you connect them, you will have 120 volts. You will ask yourself, why do we have a neutral or a ground? The confusion between the ground and the neutral, you can figure it out when you work a problem. When you come here to the relay box, you discover that the blacks are the hot wires that are connected to the main power supply that comes from the outside cables. The power cables from outside, those are the two power cables come from outside, distributed to the blacks. Each one of those will have 120 volts. Sometimes you have a white, like this white here, is connected also is an active because it has other purpose. It doesn't follow the rules, but somebody just connected it, put it as a hot wire for whatever reason it is. But generally speaking, you install a new utility in the house. Like I have here lights, garage lights. Each of these lights will have the 3 terminal, the black and white. Those are the power lines that will turn the light on and off. And the ground that's connected to the chassis. Where do they fit here? If you look here, you discover that the white and the ground, both of them are connected to the same metal bar that is grounded. So you will ask, so why do we have to have neutral and ground? Here the neutral and ground are the same thing on the relay box. But when you go to the light, when you connect the active element, which is that light, that is your active element. It has white, black, and green. And you are going to connect the active, the high potential black to the black, and you are going to connect the white to the white, and that copper, the bare copper will be connected to the green as a ground. So you ask yourself, why do we have to do that? What is the difference between these two lines, the ground and the neutral? The neutral is going to return the current to make continuity. So the current will be, the voltage will be applied between these two terminals, the black and white. The power flows from one side, and the continuity is achieved by using a ground wire or a neutral wire. Let us call it ground. The neutral, that is a copper that is connected to the chassis, has no function at all other than safety protection. Safety means when you have a fire here or a shortage, the shortage, if you have a shortage inside your active element, you are going to have a fire, going to get very hot. If that wire is cut, if the ground is cut, the fire will keep going, and you are going to have a problem because you don't have a discharge. Your discharge will be that neutral or that ground. That copper wire, when it completes the circuit, the continuity, it will trigger the relay. So the relay will cut the power supply. The relay will disconnect, will be triggered off, disconnect to the electricity to the black wire. So in other way, the only reason you have three wires here, active and ground, or neutral and ground, whatever you call them, is that one of them will keep the active element turned on. When the active element has a defect or a shortage, that ground will close the circuit, and the circuit will trigger the relay, and the relay will cut off the continuity, shut off the power, and prevent it from having greater fire. Now I'm installing a new line of lights in the home, and I created another relay, about 20 ampere relay. That 20 ampere relay have two terminals. It comes from the power supply. Look at here, every side here, that bar, longitudinal bar, will supply the power to this side, and the other terminal, which is this side, that screw, will be connected to the black, that wire. These two terminals, the white and the copper, the bare copper, will be connected to the ground on the bottom. I need to find the holes, friend. I think I have enough holes to do the job. Before we do that, we have to make sure there is no short between any of these wires in two conditions. The first condition is that there is no power already. We are just testing continuity. So we have the ohm meter set on the ohm, and we are measuring the continuity between each of these two wires when the switch is on or off. We are measuring the ohm or the continuity between each of these two wires with the copper. We should have open circuit, which means there should not be continuity when we turn the switch on or off. If you have continuity, means the ground or the neutral is connected to one of these wires, means you have a short. So here the colors now don't matter. The green and red here on this is just a connection, external connection. But that green is connected to the red of the ohm meter, and the red is connected to the black of the ohm meter. It doesn't matter the color. What matters here is the continuity. Before you do anything, you need to make sure you are not being fooled. So first you need to get these together to see if that will make it short or not. You touch this, you get a short. You open it, you get an open circuit. Let us do it again. You touch it here. You touch it here, you get a short. You open it, you get an open circuit, which means everything is functioning good. The ohm meter is not going to fool you. Now I'm going to move that from this wire to the black. We should have an open circuit. We have an open circuit. We also need to repeat the same step, touch it back and forth to make sure we are not being fooled. You touch it here, you get 0. You open it, you get open circuit. Now, we succeeded in one state. We tested one state when the switch is either on or off. I need to go upstairs and turn the switch in other position and come back and repeat the same process. We should not have continuity with the bare copper wire. Otherwise, you are going to have a short, and the short might trigger fire. So we will go up there and I show you my product. Here is the project I have. Here is the first light, and it will keep going through the attic to the end. What you see, that is the airflow because there is a fan. So you got circulation in the attic. And here is the switch. Let us turn that baby on. And of course you have no power. We are testing the continuity. We go back. If everything works good, we will power the circuit and come back to see how beautiful that will be. Now we turn the switch to the other direction. On or off, it doesn't matter. So far here, the black and the copper wire are open circuit, which is what we want. Before we go to the other line, we are going to test here, so we make sure we are not being fooled. If you touch these together, so that is working. The ohm meter is not fooling us. We take this one from here and put it on the white. Wow, we are doing good. What does it mean doing good? Means my connection, I worked on about 10 light bulbs upstairs in a very tight condition. And I have to connect these 3 wires to that light bulb. And I have to insulate and make sure I have no short. So far so good. What we are going to do now, we are going to connect everything to the power supply. The white and the copper will be on the bottom, and we are going to put our relay right here. And we made some progress. We passed the wire from the bottom hole, goes closer to where the relay will go. The relay will go here. And I finally got the relay to work. Have to use WD-40 to loosen the screw. That screw was stuck badly. After you spray it with WD-40, you wait 5-10 minutes. You hope it will be loosened up. A zip tie on the side will help you work without having to keep pushing things away. And I found an empty spot here to insert to my ground right there. This is available for me. That's, as a matter of fact, there are 2 of them. Progress. We connected the black to the circuit breaker. We connected the copper, the bare copper to the ground. We connected the white to the ground, and we put the switch off to avoid any spark, and we are going to put it in this slot. I think I have enough length to do that. Now I have a clean cut without pinching. When you use a cutter, you create that, you pinch the metal and it can break easily. You are back at it. I hope it will not cut this time. Everything have to be take time. You do it very neatly. You don't rush. Once you bench it or you make a mistake, you pay for it. We almost there. It helps you to inspect the bottom of it. It has a hook here. So you have to put that hook in, and you have the power supply, and here's the contact, the power contact. So you have to put that hole first, that hook that goes under first. You discover things by mistake. We got it seated perfectly. I discovered an extra circuit breaker was sitting there. I don't think it was connected to anything. It looks clearly that it was not connected. So that was an extra sitting in the bottom. I don't think there are any wires connected to it. That was just an extra circuit breaker. So now, if I turn that on, look at the attic now. My attic is dark. Let me turn it on and see. Hopefully I don't have a disaster. Ooh, that is great. That is great. We accomplished something. We accomplished something. So I have an extra slot here and an extra slot here. And I have an extra circuit breaker. How many scratches I have, how many punctures in my fingers. And it is cold here. This is not a warm state. And here's my neighbor in the window celebrating the Christmas. I did make progress. Look at the beauty. That is light one here. Everything is bright and great. All the way to the end. And here's my switch. Turn it off, turn it on. Wow.